In this video, we'll demonstrate how to convert a steady-state model into a dynamic simulation using Flowmax. We'll begin by building a steady-state model consisting of a pump, a control valve, and a pipeline. At the end of the pipeline, we install an emergency shutdown valve. This valve will be used later in the dynamic simulation to simulate a closure event. After completing the initial sketch, we proceed to define the model parameters. We begin by entering pressure boundary conditions at the inlet and outlet, piping details including length, diameter, and elevation for each segment. Next, for the control valve, we specify its CV value and set the flow rate as fixed for the steady-state simulation. For the pump, we input its performance curve to define its behavior under different flow and head conditions. These inputs allow Flowmax to calculate pressure and flow distribution throughout the network. To amplify the surge effect during the ESDV closure, we increase the pipeline length. A longer pipeline allows pressure waves to develop more significantly, making it easier to visualize and analyze transient behavior in the system. In the steady-state mode, the valve operates with a defined flow rate set point. However, when switching to dynamic mode, all equipment must operate in rating mode, meaning no active control targets. For example, the control valve should not have a set point, and the pump should operate based on its characteristic curve. Once the model is converted to dynamic mode, we'll add a non-return valve at the pump outlet to simulate reverse flow prevention. To simulate a valve closure event, we'll assign a controller that defines the valve opening percentage over time. In this example, the valve will close over 10 seconds. After running the simulation, we observe that the surge pressure is high. To mitigate this, we change the valve type to equal percentage, which offers a smoother closing profile. To observe the surge pressure profile, we add a pressure chart and attach it directly to the flow sheet. This provides a clear and dynamic visualization of the pressure variations during the simulation, helping us quickly assess the impact of valve operations and system transients. Running the simulation again, the surge pressure is noticeably reduced. We can lower it even further by reducing the valve CV value, which adds more resistance and dampens the transient wave. As you can see, Flowmax Dynamic Mode provides powerful tools to simulate and mitigate transient surge events effectively. Flowmax, your best choice for transient hydraulic simulation.